Okay, so this is problem 5.3.38, and they ask us, or they tell us, that there are only two solutions in integers for a squared plus 4 equals b cubed, and then they tell us that one solution is when a equals 2 and b equals 2, and they want us to find the other solution. There really is no process for this other than just trial and error. This is, a number sense kind of a problem. And one of the things that you want to look at is because um, because you're squaring a number here and then you're adding something relatively small, but over here you're cubing, you're going to be thinking of this a, trying numbers of a that are actually going to be a little bit larger than your numbers of b. And the reason for that is because, when you square something, you're multiplying it times itself, and when you cube it, you're doing it 3 times. So this is going to amplify. Cubing amplifies the number more quickly than squaring does. So that logically means then that this number needs to be larger than this number. Not always. You can see that one solution was a equals 2 and b equals 2. But those are relatively small numbers. Okay, so let's just try a few things here. Let's say that I try 8 squared plus 4, and let's say down here, well, actually, one of the ways to do this is to just plug in values of a, so if I'm using a value of a here and I'm saying 8 squared plus 4, that's 64 plus 4, and that's 68. And then I want to think about, is that number there something cubed? Can I write an integer as something cubed to give me 68? And I can't. So to maybe be more precise, maybe I should start a equals 2, we've already seen. Let's try 3. So 3 squared plus 4. That's 9 plus 4 is 13. Is there a number that cubes to give us 13? No. If I try 4 squared plus 4, so that's 16 plus 4 is 20. There's no number that cubes to give us that. 5 squared plus 4, that's 29. Okay, so none of these are working, is what we're saying. 6 squared plus 4, that's 36 plus 4 is 40. There's no number that cubes to give us that. 7 squared plus 4, it's 49 plus 4, so that's 53. That doesn't work. We've already tried 8. Let's try 9. 9 squared plus 4, that's 81 plus 4 is 85. 10 squared plus 4, that's 100 plus 4, that's 104. The next one will actually be the one that will work. So 11 squared plus 4 is 121 plus 4 is 125. And I can think of a number that is going to cube that would give me 125. And that number is 5. So this is 5 cubed. So you can see that this equation right here becomes true if my a is 11 and my b is 5. 11 squared plus 4 is equal to 5 cubed. So this is, 121 plus 4 equals 125. That's 125, 1 equals 125. So in this problem, you're looking at a equals 11 and b equals 5 as the other pair that makes this true, the other pair of integers. And so really it's just a process. So what I did was I fidgeted with this side to see if I could get a number, any of these numbers, that I recognized as something cubed. Okay, and I kept going until I got that number. And that's really the only way to do it. There's no sort of other process. This is just a logical way to think about it. Okay.